4.4 complex numbers. The whole world is going to change for you guys today because up until this point, the answer to this problem, the square root of -4, has always been no solution. You can't square root a negative number because anything times itself is a positive. Negative times a negative is a positive. Positive times a positive is a positive. There's nothing that times itself equals a negative. That changes after today's lesson, so it's really exciting. But first, before we do that, let's refresh on simplifying radicals. So if we have a radical, we always want to write it in simplest radical form. If you remember this from Algebra 1, this is when we do a factor tree. So we want to break up this 50 into two factors. Let's say we started with 25 and 2. Okay, and there's really two ways we can do this. Okay, so we break it up to 25 and 2. Now I like seeing this 25 here because I know that 25 is a perfect square. The square root of 25 is 5. Okay, which means we can write our answer. 5, that came from the square root of 25, and then that radical 2 is left over. So the simplest radical form of radical 50 is 5 radical 2. Okay, let's do the same problem a different way. So we have radical 50 again. All right, and let's say instead of 25 and 2, we did 5 and 10. Okay, this time we don't have a perfect square. Okay, we want to keep going. So 5 is a prime number. That's the bottom of the factor tree on that side. But 10 is not. We can keep going with that one. So the 10 becomes 5 and 2. All these numbers are inside radicals. Now, when we did this one, we don't have any perfect squares. So there's no numbers up there that we can actually square root. But we do have two of the same things. So we have 2 radical 5s. Now, all those numbers, the 5, and the 2, if we multiply the 5 times 5 times 2, it turns back into the 50 up here. Okay, but let's say we multiply just the 5 and the 5. That turns into square root of 25. Okay, and we know from over here, square root of 25 is a 5. Okay, point being, anytime we have a pair of numbers that are the same, it's going to turn into one that moves outside the radical. Okay, because really it's just a 5 squared inside a radical, and the radical and the square root would cancel each other out, and this guy moves to the outside. Okay, so when you're doing simplified radicals, you're looking either for a perfect square, like a 25 or a 16 or a 100, or you're looking for two of the same thing. Okay, and if you have two of the same thing, you can just jump it right to the outside. All right, so number 2. Okay, we can start these off with any batch of numbers that you want. It doesn't matter how you start it off. It's always going to end as the same thing. So I'm going to say 4 and 6. Okay, now 4 is a perfect square. Square root of 4 is 2. Okay, 6 is not. 6 is 2 and 3. Okay, now I didn't just make that a 2. It looks like I broke it up into a 2 and a 2, and that's fine. All right, so now I have 2, 2, 2, and 3. Okay, I have 3 2s. I can only take out 2 at a time. So I have a pair of 2s here. This is going to turn into 1, 2 on the outside. And these don't have any partners. Okay, we need another one that's exactly the same to move them to the outside. So they're just going to go back together and turn back into this 6 that we had up here. Okay, so this is going to move to the outside, this 2. Okay, these guys combine because they can't move to the outside, and they go back inside to the radical. Combined, 2 times 3 gives us a 6. All right, so up until this point, everything that you've dealt with in every one of your math classes has been a real number. Okay, and that changes in this section because what we're learning about in this section are imaginary numbers. Okay, the square root of -1, which you've never been able to do before, is now this variable lowercase I. Okay, that's an imaginary number. Okay, it doesn't actually exist. It's not actually possible to do this, but allows us to solve some complex math problems. So all those problems that we used to be able to just draw that big 0 with a line through it and say no solution, we're finished. Okay, we can't actually do that anymore. We're actually able to solve those, and we actually have to solve those. Now, since the square root of -1 equals I squared equals -1. And the rationale behind that is that if we were to square this, we were to square this, that squared and that square root cancel out. Okay, and then -1 remains. Now, An I with any exponent is going to simplify, and this is actually a cyclical set of patterns here. So I cubed, if we just wrote three i's, okay, the first two i's make an I squared, okay, and an I squared, like we set up here, is a negative 1, okay, and this is really just a negative 1i. Let's look at I to the fourth, okay, we have a pair of i's here and another pair here, so we really have I squared times I squared, or negative 1 times negative 1, which we know is positive 1. I to the fifth, I squared, this I is left over, negative 1 times negative 1, this gives us a positive 1 with an I left over, 1i. All right, now the pattern that this goes through, if we were to go to I to the sixth, okay, we're repeating a pattern at this point, okay, and the pattern goes I, negative 1, negative 1i, 1. Okay, once we get back, once we go to I to the fifth, we've actually restarted the pattern. Okay, so we're now back at the start of the pattern. Okay, I to the sixth is going to simplify to negative 1. I to the seventh is going to be negative 1i. I to the eighth is going to be 1, etc., etc. All right, now with that in mind, let's simplify all of these. Okay, and the key things are that anytime we have an I squared, it's a negative 1. Anytime we have an I to the fourth, it's a positive 1, because that's really just a negative 1 times the negative 1. So let's say we have I to the seventh. And let's start it off simply by writing out all those i's. Now, if we looked at this, okay, and we grouped all of the pairs of i's together, okay, we can see we have 3 pairs of i's and we have 1 left over. And that's really the first thing that we want to determine, is that is there going to be an I left over, or are all the i's paired up? Okay, and we can tell that by just looking at this exponent and seeing, is it even or is it odd? If it's odd, there's an I left over. All right, so we have 3 groups of I squareds. I'm going to write it like this: I squared to the third power, because there's 3 groupings of them. All right, and we know that I squared is a negative 1. Okay, so it's really negative 1 cubed. Right now, is negative 1 cubed going to be a positive 1 or a negative 1? It's a negative 1, so this turns into negative I, or negative 1i. Number 4, okay, we have I to the 81st. Is there going to be an I left over here? Okay, there is, because it's odd. All right, next question. I'm not going to write out 80 i's here because it's going to be a pain. But what I want to know is, how many pairs of i's do we have? Okay, so if I made this I squared the sum power, how many pairs of i's do we have once we take out that leftover I? All right, so I'm removing that extra one. Okay, and once I remove that extra one, there's 40 pairs of i's. So really, this gives us 80, and this is the 81st. Okay, now the question is, what's this give us? Does this give us a positive 1, or does this give us a negative 1? Okay, so this is really negative 1 to the 40th power. Okay, it's being raised to an even number. We're going to have an even number of negatives, which means this becomes positive. So this is positive I. Number 5, 120. All the i's are paired up. We don't have any left over. So this is just going to be I squared to some number, okay, with no extras. Okay, in this case, it's 60. It's just half of it. Okay, remember your exponent rules. We would multiply those exponents if we went backwards. All right, negative 1 to the 60th power. Again, it's even. We won't have an I in our answer for this one. It's either going to be 1 or negative 1. Since it's even, this becomes positive 1. Lastly, number 6, this is odd. It's going to have an I in our answer. Okay, let's take out that I first. Okay, and then find what's left over. So there'd be 298 left over. Cut that in half. I squared to the 149th power. Since this is odd, this whole thing is going to equal negative 1. So negative I is our answer. Those are the only 4 answers we can get. I, negative I, 1, negative 1. You can't get anything other than that. All right, so just like those first couple problems where we simplified radicals, we can simplify negative radicals. We do it the same way. We just also are going to have an I in our answer. Okay, so for a problem like this, right, we're going to split up our 18, and we're going to have a 9, a 2, and this I. Okay, that 9 we know is a 3. Okay, when we write it out, we write the I on the outside, and we write it right after any numbers that we have. So 3I, this 2 stays inside that radical sign. Number 8, okay, break this up. Again, it doesn't matter how you break it up, so you can do 10 and 2, and then split the 10 to a 2 and a 5. Okay, just remember that we have an I in there because of this negative sign. Okay, the 4 is a 2 and a 2. Anytime we have 2 of the same thing, okay, that turns into a number on the outside. I goes right after that number, and this didn't have a partner, so he stays inside. Again, we're looking either for pairs of numbers or things we can square root. And these last two, let's say we have something like this where we do 10 and 6 on this 60, okay, and then we're going to go ahead and split both these up. 5 and 2, 2 and 3. Okay, again, we have a pair of 2s. Those are going to go together. That's going to move outside. We have the I on the outside. Okay, 5 and 3 don't have partners. They're going to stay on the inside. We have to multiply those together. 2I, 15 comes from multiplying that 5 and the 3. All right, and if you have a big number like 243, start small. Okay, so 2 doesn't go into this, obviously, because it's not even. All right, let's try 3. Okay, 3 does go into it. Okay, now maybe you recognize that this is a perfect square. It equals 9, but maybe not. Okay, and maybe you just keep breaking it down. Okay, and you came up with 3 radical 27. That's not a good answer. Okay, because it's not in simplest radical form. We can keep breaking down this 27 and this 9. Okay, now we have a whole bunch of 3s. Right, there's a pair of 3s here. There's a pair of 3s there. There's 1 3 left over. Okay, if we took out 1 3 here, multiply it with this other 3 here, we get this 9 that we had originally gotten way up here. Okay, just make sure it's fully broken down when you write your answer.